Second derivative test. As we learned in the Year 11 course, we can identify stationary values by finding x-coordinates where dy dx is equal to 0. We know that we can use a sine test to determine the type of stationary value. Just as a reminder, and we will look at this in the examples, what you normally do is something like x and dy dx, and say you've got a turning point at 2, and then you might look at 1 and 3. Well, you know dy dx is 0 here, and let's say you get a positive followed by a positive, then it goes like that, and you can see that you've got a point of inflection. You can also do that just with a number line and say, okay, well 2 is here, that's where the gradient is 0, and let's say it's negative here and positive here, negative gradient, 0, positive gradient, that would be a minimum. Now that we've investigated concavity in the second derivative, we can also use the second derivative test. If d2y dx squared is a positive number, we have a local minimum because we know the curve is concave up. If d2y dx squared is negative, we have a local maximum because the curve is concave down. However, if d2y dx squared is equal to 0, it could be any type of stationary point, as we have seen when we looked at y equals x to the 4, which had a minimum. So we need to go further. We can either revert to a sine test using dy dx, as we discussed over here and in the Year 11 course, or we can look at d2y dx squared, either side of the stationary point. Effectively, that is a second derivative sine test. So you have a sine test with the first derivative or with the second derivative. And you would need to do this if you found d2y dx squared was 0. You can't just say it's a horizontal point of inflection. And as I said, we've seen that. So let's look at that second derivative test. Here we see we've got a curve that has a concave down shape, followed by a curve that has concave up. That's going to be a horizontal point of inflection. So what we can see there is that we would have a negative value for d2y dx, followed by a positive value. So if we were doing that on a number line, and let's say this point was 2, we have 0 at 2, which is why we're doing this test in the first place, and then we get negative positive, and that tells us concave down, followed by concave up, point of inflection. And clearly this one just is the same, but it goes up followed by down. On the other hand, if we have concave up either side of a 0, so on a number line that would look like this, let's say that was at 2 again. So to be concave up, positive and positive, and then that tells us that we have a minimum. And of course, if it's down followed by down, we have a maximum.